Hello everyone, welcome to my class. As you know that the world of statistics is very big. But the foremost and the most welcoming chapters we generally see in statistics are correlations and the chapter of regression. So undoubtedly our today's chapter will be the regression analysis or analysis. So what we will understand today are very common topics. In order to learn regression analysis, we will start with a little introduction. Then we will understand what are the type of regression analysis. Then we will understand why we use regression analysis. Then we will understand what are the main terms that we use in regression analysis without which we cannot solve any problem of regression. And then we will solve a simple example of the first phase of learning regression, that is a very simple regression. So let me introduce you to the regression analysis in statistics. As you know, we all run, right? When we run, it affects our calories, right? The more we run, our calories reduce. It means running has a relationship with calories. It means running affect our calories. So, for example, a guy is running. When he runs 1 kilometer, his calories reduce by 50. When he runs 2 kilometers, his calorie reduce 120. But when he runs 3 kilometers, he was able to reduce 300 calories. After seeing that how his calories were reducing, can we really predict or can we really guess that if he runs 4 kilometers, how much calories he will reduce or how many calories he will reduce? Yes, we can do that. Sometimes we know about how one variable affect another variable from the past data. Yes, we have a data of the past 1 kilometer, 2 kilometer and 3 kilometer. And we know how it was affecting the calories. Can we predict for future upcoming values of another by seeing its past behavior pattern? Can we really predict that how many calories we will reduce if we run 4 kilometers? Yes, of course we can run, and there's how we come into the touch of a chapter we call regression analysis. Yes, we can by using a methodology in research or in statistics that is called going back. Going back means learning about the past data, its pattern, and predicting the value of the next outcome. And that is called regression analysis. And this is the reason we use regression in statistics. Now, because you know a little about regression analysis, let's study it further and learn about type of regression analysis. As you know, I was running, right? And it was reducing my calories, so there was a relationship between running and calories. So earlier, only running was affecting my calories. So there was a relationship between two variables, running and calories. When you study only one variable affecting another variable, so the variable which is affecting is only running. So this type of analysis is called simple regression analysis, in which only one variable affect the another variable. But what if I say that I am also doing cycling as well, because cycling also reduce calories. So now I am studying two variables affecting one variable, that is calorie. No, we cannot solve any problem of regression if we have two variables. With simple regression, we have to shift our energy towards a new type of regression analysis that is called a multiple regression. So we use a multiple regression when we have two variables. Now you know I was running, right? I was running 1 kilometer, my calories were reducing 50. Then I start running 2 kilometers, my calorie reduced to 100. And when I start running 3 kilometers, my calorie reduced to 150. Did you see anything similar here? Yes. When you run 1 kilometer, calories were 50. When you run 2 kilometers, calorie reduced to 100. And when you run 3 kilometers, calorie reduced to 150. It means there is a proportionate change in both the variables. In more running, there is a gap of 1 kilometer, and in running calories, there is a gap of 50-50. Do you really know that you cannot do a simple regression and you cannot do a multiple regression, or you are always set to avoid doing simple regression and avoid doing multiple regression if variables are not behaving like this? Yes, running and reduction in calories should always be proportional. Otherwise, doing simple regression and multiple regression can give you wrong results. So keep in mind. So if you put this relationship on a graph, right, you will see this kind of relationship. This relationship is called linear relationship, and such kind of study in statistics in regression is called linear regression. It means there is one more type of regression that is called linear regression, and linear regression can only be suitable on simple regression and multiple regression type of data. So I will always suggest you to avoid doing simple regression and multiple regression if data is not behaving in a linear way. It should be linear and it should be little close to linear. Otherwise, doing these both type of regression is not suitable. So currently we have three type of regression: simple regression, multiple regression, and we have one more is linear regression. So if we have linear regression, the data was having a proportional relationship. But not always data have proportional relationships. So when data do not have a proportional relationship, or it is very much not proportional, so you will use a non-linear regression. Our today's topic will not be on non-linear regression, but I will tell you what non-linear regression is. Look at these two variables, labor and per out unit labor output. As you know in earlier classes that in economics, when we use more labor, the productivity start increasing initially. But later, if we start using more labor, the productivity start reducing. It means the per unit labor you are putting, they are giving you less amount of output. And this particular phenomena is called as law of diminishing returns. And we see that the relationship between both labor and per unit labor output is never linear. It starts shifting its shape. When your data behave like this, or when your both variables are not behaving proportionally, you have to shift your energy towards a new type of regression analysis that is called non-linear regression. But our today's topic or class will be on simple regression. So we will shift our energy towards a linear regression type of data which is highly proportional. So let's start learning that we have learned little about regression analysis. Let's start learning why we use this amazing chapter in statistics, and these are some very good reasons. We know very well that regression is used to predict the value of a variable. For example, you were running 4 kilometers and we wanted to know how much calorie we reduce. Same kind of situation is faced by business as well. And let's learn about the first use is that we can predict the value of profit, which is a variable, by watching the sales and profit relationship in the past. We can predict the demand by watching demand and supply in economics, by watching its relationship in the past. We can predict the returns by watching risk and return in stock market and also in business by seeing the relationship of risk and return relationship in the past. Not only that, we can predict the recovery rate of patient in if we talk about medical industry by watching patient recovery rate and dosage of medicine relationship in the past. We can predict population growth by watching the relationship of migration and population relationship in the past. See, regression has some amazing uses. But one common word we see here is that it is used to predict. It is used to predict the value of another variable with the help of one variable which is affecting it. So it has so many uses, and because now we know the use of regression analysis, let's start learning about the important terms of regression analysis in statistics. So the first thing we must learn is about independent variable. An independent variable is one in our case was running. Running was an independent variable. We can change it to see an effect. It will affect the calories. That is why it becomes the cause. Yes, it is a cause because it affects our calories, or it becomes the factor for affecting the calories. So in regression, we always put independent variable as x. Now, the dependent variable is called y, and it is the variable that is affected by changes in the independent variable. So whenever you make any changes in the running, it will affect the calories. So calorie is affected by a variable called x. So now we must learn two amazing terms, x and y. X is an independent variable, always will be, and dependent variable will be y. Now we should know one more term which is very crucial in this chapter is intercept. Intercept is said by the word a. Remember, as you know that when we're running 1 kilometer, a calorie were reduced to 50, 2 kilometers calorie reduced to 100, and 3 kilometers calorie reduced to 150. What about if the running was 0? Still it can impact our calories, but we don't know how much. So intercept is a value which is when x is 0, what can be the value of y? Sometime it will be given to you, but sometime it will not be available to you, so you can find it out. Now we should learn one more term here is regression coefficient. A regression coefficient in statistics is represented by the word b. It is the rate by alphabet called b. It is the rate of change in y due to a unit change in x. So if 1 unit is change in x, how much it will change y? This is called regression coefficient. If the independent variable changes by 1 unit, then the dependent variable changes by 2 unit. So it is called regression coefficient represented by alphabet b. Let's see one more situation. If it reduce by 2 units, it's a negative regression coefficient because one variable is increasing and another is decreasing. And if it increases by 2 units, it's a positive relationship because if one variable is increasing, another variable is also increasing by 2 units. So it's a positive regression coefficient relationship. So, in order to learn stat regression, it is very, very, very useful and very important to learn these four topics: independent variable x, dependent variable y, intercept a, and a regression coefficient b. Regression coefficient tells you what kind of relationship two variables have. Intercepts tell you what is the value of x when value of y is 0. So we will change a little in this thing. What is the value of y when the value of x is 0? So it was done by mistake, right? What is the value of y when the value of x is 0? So this is called intercept. Let's see our data, right? When we were running more, we were reducing calories, right? So running will be x here and the calorie reduction will be y here. Now let's see when we were running 1 kilometer, calories were reducing 50, 2 kilometers 100, then 3 kilometers it was 150. And when we started running 4 kilometers, we don't know how many calories were reduced. Yes, we can predict it by forming a mathematical function with help of all these four important terms, and that is called this. This is called a mathematical function to find out the value of 4 kilometers calories. So y will be calories is equal to a will be the value of y when x is 0. It means the value of calories when running is 0 plus b. B tells you how much calories are reduced. What is the rate of change in calorie when you are running every single kilometer? and x will be the value of run. So do you know that you can find or predict the value of the next running reduction in calories by this mathematical function, and it is the mathematical function of regression analysis. Y is equal to a plus bx. Now remember, you have x, yes I have x. Do you have y? Yes I have y. But what I don't have is a and b. So in regression, very important topic is to find the value of a and find the value of b. So there are separate formulas for a, finding the value of a, and separate formulas finding the value of b. Sometime in questions it can be given to you, then when you are not running, when you're running 0 kilometers, how many calories are reduced. So there's no need to find a, but it is always important to find a and b both. So a can be given to you, and if it is not given, you can still find it out. So let's first solve a problem of a regression. As you know that the relationship between two variable should always be if it is proportional. If one is increasing, other is also increasing in a constant rate, then you must use simple regression or multiple regression because they are more suitable and they will give you always good results. So let's solve a problem of simple regression. Can you see the data? Yes. In the data, you can see one variable is increasing at a constant rate and another variable, that is rice growth in centimeter, is increasing in constant rate. So it is true that I cannot use non-linear regression. I must shift my energy towards linear regression. And in linear regression, I have to go for simple regression because I have only two variables, one independent variable. So you know when there is only one independent variable and it is affecting the one dependent variable, so we have to do a simple regression. And we remember that if we were having two independent variables, we have to do a multiple regression, or more than two variable, we have to do a multiple regression. So in our example, we have rainfall. When there's a rain, there's always increase in the growth of rice because you know water is very crucial for the growth of rice. When there is zero rain, still rice grow by 0.5. So what we see is that we have rice growth is there even when the rainfall is zero. So we already have an intercept, that is A. But I will still show you how to find it out. But when the rice grow by 1 centimeter, when the rain grows by 1 centimeter, the rice grow by 1 more kilometer, by 1 more centimeter. And when the rice rainfall happens 2 centimeters, the rice grow to 1.5. It means the rice is growing 0.5, zero point 0.5 and zero point 0.5, and the rainfall is increasing 1 centimeter extra. So you can see there is a linear regression and it is a constant change. So it is very much suitable for us to use simple regression because we can do that in case of linear regression. So as you know, we have the value of x and we have the value of y. We must solve a, that is intercept, and we must find out regression coefficient, which is the main item in the list, that is b. So I have a solution for this problem. So let's see how to solve this. The formula for regression coefficient, you know, it is called b. It is n total of x into y minus the total of x, the total of into total of y divided by n represents the total number of outcomes we have. We have total 8 outcomes, and in the 8 outcomes we have 8 uh, values of y. So n in the total of the square of the total of the x minus the sum of the x, then its square. So if you use this formula, first of all we will total the value of x. The total of rainfall in centimeter is 36. Total of the rice growth in centimeter is 22.5. The square of each value of rainfall in centimeter is 0, 0, 1, 1, 2 square 4, 3 square 9, and this is how total it will be 204. And next thing we have to find out is xy square. So you have to multiply x with y in each outcome, and then you have to square it. So by mistake I have put it xy square. You just need x and y. So you will total x and y, and it will be x 120. So we need 4 items to solve this regression coefficient. Is sum total of x, sum total of y, sum total of x square, and sum total of xy. Okay, and when we put these values in our formula, we will find out the regression coefficient, that is 0.5. 0.5 means the rate of change when x changes in y is 0.5. If there is a 1 centimeter change in rainfall, there is 0.5 change in the growth of the plant, that is rice. As you know, after solving this problem, we have b with us. Now we must need an a. We already have an a, that is value of x when y is 0. What is the value of x when y is 0? It is 0.5, as you can see on the top of the list. But still I will teach you that how to actually do that. The value of intercept can be found out. If you really want to find out the value of a, you must need b. Remember, you cannot find out a without knowing the value of b. As you can see the formula, there is a summation of y values minus regression coefficient into summation of x values and divided by the number of outcomes we have. If you start solving this problem, you will find out that the value of a was the same as in the data, that is 0.5, and we have find out that the value we have found out with the help of formula is also same, that is 0.5. Now because we both have a and we have our b, we can easily predict the value of any outcome in the question. So look at this data. When the rainfall happened 8 centimeter, the rice grow from 4 to 4.5. So can we predict that what will happen and how much growth of rice will happen if the rainfall happens 9 centimeter? Of course we can predict it. Now we have a, now we have b, and now we can form our mathematical equation, that is y is equal to a plus bx. So we can know the value of y because now we have the a plus b, because I told you it was very important to find both these items, without which we cannot find the value of rice growth. So look at this picture. When we have a mathematical function here, y is equal to a plus bx. It is also called value of y when x is given. So whenever we have rainfall in centimeters, we can predict the value of y, that is the growth of rice in centimeters. We also call this line regression line of y. Remember, it is the regression line of y because we are predicting the value of y. So regression line of y on x. We can also call it line of best fit, and we can also set this particular mathematical function as regression equation. Now look, let's try to see what will happen. If rainfall increased to 9 centimeter, so 9 centimeter is the value of y, then what will be the value of plant growth? We know the plant growth is known by a term called y because it is dependent variable. So y is equal to a A is our intercept, that is zero point 0.5, we just find out, and it is also given in the data, plus B, that is regression coefficient, that is also zero point 0.5, we have just find out with the long formula, into the value of x. We know we wanted to predict the value of rice growth when rainfall is 9 centimeter. So we will put the value of x, that is 9 centimeter, and we will solve this problem, and then we will find out that the value of y is 5. It means when the rainfall happens 9 centimeter, the growth of rice will be 5 centimeter. And it's also very clear with the data as well. When the relationship are so linear, we can predict that when the rainfall grow by 1 centimeter, it of course the rice will grow zero point 0.5 more. So the next value will be 5 centimeter. But sometimes relationship are little close to linear, so predicting them it can be little difficult. So that is why simple regression is very effective and useful in our life. So thank you so much. What we learned today was very interesting topic, that is regression. That is very crucial part of every business life, and also crucial part of our daily life as well. We can predict the value of one variable with the help of another variable, and that is why we use regression. We learn regression with a very systematic process, and if you can solve a simple regression, you can also solve a multiple regression as well, because there's no much difference. The only difference is that the calculation is little more, but the ideology and the base will always be the same. So thank you so much. Let's solve more about regression in our next video. Thank you.